Hi, my name is PV, and today I'm going for BigQuery. So, in this BigQuery, we will go why we need BigQuery or introduction of BigQuery, then architecture of BigQuery, and injecting data into BigQuery, and accessing BigQuery various different method like using GCP Conjure, and next is using the BigQuery CLI and use cases of BigQuery and partitioning and clustering. So if you subscribe my channel, you may have learned about my previous lecture about Bigtable, where we learn about Bigtable, which provide a low latency, high performance with a petabyte of data, but Bigtable is very costly. So to overcome this problem, we come up with cost effective for analysis of terabyte to petabyte of data uh, with the latency would be little bit more here. BigQuery is the right choice for that. We have used BigQuery while creating billing exports. Let's see the BigQuery in detail in this lesson. So BigQuery is a GCP serverless, high scalable, cost effective and cloud data warehouse. It's allow for super fast query and petabyte scale up using processing power of Google infrastructure. Because there is no infrastructure for customer to manage, they can focus on uncovering meaningful insight using familiar SQL without the need of database administration. It's economical because you pay only for processing and storage you use. BigQuery is part of Google Cloud Comprehensive Data Analysis platform that cover entire analysis value of chain, including injecting, processing, and storing data. So it's a kind of the Hive table. If you know about Hive, it's a similar to Hive. So architecture, if you see here, the BigQuery and distribution memory shuffling, petabits networks, high available cluster compute, and this is the replica will be here, and using the stream inject we can do, pre-bulk load also we can do, and client library in the several languages like REST API, Web UI, CLI, SQL so it's also SQL supports. So BigQuery architecture has Dremel compute service of large multi-tenant cluster that executes SQL query. Storage is a Colossus Google Global Storage System. Google Globus. Okay, compute and storage talk each other through the petabit Jupyter network. BigQuery is a orchestral via Borg and compute processor of Kubernetes. So these are the behind the architecture, so you don't have to worry. So if you know about SQL, so it support the ANSI standard of SQL, so you can use the BigQuery. Now the next part we are talking here is injecting data into BigQuery. BigQuery supports several the way to inject data into managed storage. The specific injection method depend upon origin of data. For example, some data sources GCP like Cloud Logging and Google Analysis supports direct export to BigQuery. BigQuery data transfer service enable data transfer to BigQuery from Google SaaS apps and Google Ads Cloud Storage, Amazon S3, and other data warehousing like Teradata, Redshift. So you can use the data transfer from various, the cloud services or cloud storage. Streaming data such as logs, IoT device data can be written into BigQuery using cloud data flow pipelines. So GCP has cloud data platform which can be used for streaming process. So I will go to the in the next coming my lecture. Cloud data proc jobs or directly using BigQuery stream injection API. There are high levels data pipeline data service. You can also ignore these for now. Just remember the way you throw which you can image the data in the BigQuery. Now this is the we understand data injecting and architecture of BigQuery. Now we are going here how to access. After storage we need to read data. So accessing means reading of data. There are various way to read data. First one is using GCP console. So console, you can run the query using command line tool based BigQ, making call BigQuery using REST API, using variety of client libraries such Java, .NET or Python. So there is way. So using GCP console, so we will go to the GCP console. So main menu, and then we select big data and then BigQuery and the frequent update of UI of GCP. So might see the difference UI from which. So this UIT, you just go the big data and then go to your BigQuery. Then you see the explorer like this. So here is a feature info, shortcut, hard review feature, add data editor. So you need to click on query editor. So on the query editor on the left panel, you can see you can search data sets. So GCP head start educative, this one we have cloud pricing export, GCP billing exports, we have this table. So add the data, you can use the add data sets in the project, and project is a contain the data sets and data set contain the table, and expand project the left pane. Data set is a collection of data, table is a unit of hierarchy, all the data in the table. So the BigQuery project different than GCP project. You can also have multiple projects listed in BigQ, just logical separation of data sets. The right side of all about the resource specific option, the option changes as per resource selection. So data source, resources, you can search here. Search here is Stack Overflow and click on dataset view or datasets. So Stack Overflow data we have, it's a public data. So searching just search like this, post of answer, click on query table, click. So when we go here, public dataset, Stack Overflow, they have different tables. So we are going for first answer, then we just click here, then it will come, the big data, public data dot Stack Overflow dot table name. So it's kind of project name, and then under the sub level and then limits, and then query of table, query is GB data. So this is a structure, and you can go. The next one is using CLI. Try to be BigQuery, and then we do hyphen use legacy is equal to false, dry run equal to like the same query we can run. Dry run is very important. It's provide the cost estimation of query. Most optimize have the policies to approve the query cost. Hence, knowing the amount of data going to process is very crucial, right? So using CLI we can also go using use case of Big. So now we go through like how we select data using CLI and BigQ. There are various way. Now we just want to know what is the use case of BigQuery. So have a 360 view, means all from end-to-end view of the business. The cost storage of data processing reduce. Enterprise want to process, storage, analyze, and all relevant data sets, both internal and external to their organization. So if you want to view all your business, then you can use the BigQuery. Be situational aware of responsive of real-time business event. Enterprise need to gain insight from real-time events, not wait 2 days, a week, analyze of data. The data warehouse need to reflect present states of business all the time. So it's real-time also we can use. Reduce time up to insight. Enterprise need to get up and running fast without waiting days or month. Hardware or software installed in the configuration. So if enterprise they don't like to install the software, they directly access GCP and they can put data and analyze, make secure their data and govern its to use. Now, so these are the some of the use cases in the example. You can also go to the Google page and see where we are using BigQuery. Now the next part is partitioning and clustering. This is same like the Hive, but let's understand the concept. So BigQuery is known for the cost saving, efficient data retrieval mechanism. Partitioning and clustering are one of them. Apart from the BigQ, also query caching and reduced data processing. In the partitioning, data is a group of together in the basis frequently accessed column in the where clause. So processing done only specific partition. Most of time a month used for partitioning. So partitioning depend upon company to company. Some company use DS is the business date, some is use month. Clustering is way of club frequency access column together. It's provide efficient nested search. Okay, to know more this concept detail compute. So this is link I will provide. Okay, so this is for partitioning. So partitioning and clustering we will go here. You guys can do this introduction of BigQuery and the creating setup, how to do here example, then the datasets and query from table, same as which we learn. Creating new tables also we can do create new tables like using the syntax, and then creating query and partitioning table. So this is the partition, we create this partition. So partition means it give the faster retrieval of data. So here partition is here if the creation date is partition. The creating query clustered is the same column put together, so frequently access, right? So the syntax would be partition by this one and cluster by tags. So same tags is the column together. It's Android near, so it will give the faster retrieval data. So please likes and subscribe my channel.